Hello, and thank you for joining me here at IST in our design thinking room today. For the next 20 minutes, we shall dive into the world of sensor elements. And after a short introduction, I'll use examples to demonstrate how the measured signal from flow sensors can be evaluated and then turned into new additional product features. Allow me to first shortly introduce our company. Innovative Sensor Technology, better known as IST, is in the market for 30 years now, and our headquarters as well as production facilities are located here in an Alp Valley in the northeastern corner of Switzerland. Our core know-how lies in the combination of thin film and thick film technology, which we apply to different substrates, the standard being ceramics. We cooperate closely with our customers to create sensor solutions tailored to their requirements in assembly as well as to their applications. In order to manage the resulting product variability, we have an quality system in place which encompasses different standards originating from various industries. In this regard, besides the ISO 9000 standards, it might be worth mentioning that we are the only manufacturer of thin film temperature sensors that are qualified by the European Space Agency. As customers who have cooperated with IST in the past can surely confirm, we tend to involve our R&D experts in new projects on a very early stage. And that is because their creative power is the driving force of our innovation. Just as the manufacturing operators are the grease for and a good relationship with our customers by allowing us to deliver high quality products. In total, IST has 400 employees who generate an yearly turnover of roughly 100 million euros. And since 2015, we belong to the privately owned Swiss corporation Endershausen. In our standard product portfolio, you will find over 4,000 different sensor elements for temperature, flow, humidity, as well as biosensors for glucose and lactate. We often act as a technology and assembly partner, taking up different roles during sensor design, prototyping, ramp up, all the way to an efficient high volume production. And the IST sensors then find use in many different industries. The displayed ones being only a few prominent examples. For me personally, it's always fascinating to see and experience with our customers how, based on completely different criteria, the same standard elements can be selected for various applications and then integrated into always new sensor solutions. As a small example, in aviation, a flow sensor is required to operate for many years, while the same sensor element can be also integrated into a disposable medical device where the operational lifespan of the sensor is in hours or maybe even minutes. But still, both of them, of course, require a low drift sensor. At the first glance, a flow sensor optimized for controlling a large-scale ventilation system might look the same or even be the same design as a sensor dosing lubrication oil or a sensor integrated into an injection molding machine. But as they say, the devil's in the detail, and the know-how lies in the ability to cover the crucial last 10% on the road to a new product in real time. So let's now concentrate on flow sensors. For us at IST, this means mass flow sensors working on a thermal or capacitive principle. People are serious about perfecting devices for flow rate measurement, at least since the Renaissance time. And a hot wire anemometer has been around for decades now. So what makes a thin film mass flow meter so popular and worth our time today? The first reason is definitely simplicity. Just as in science, in sensor technology, the simplest, easiest solution is often the best. And a thermal flow sensor has no moving parts, is long-term stable, and requires relatively simple electronics. That is why you find them at the heart of many detectors, switches, as well as controllers and meters. Another good reason for the vast number of applications our flow sensors cover is their adaptability. And by this, I mean not only the physical scale, the possibility to miniaturize the sensor and balance the measuring range versus the sensitivity. Just as important is to have a well-defined well characterized sensor system when you are moving into uncharted territory. Imagine that you are tasked to design a new meter for a medium which you haven't measured before. The first sensor that you will be testing is one that you are the most familiar with. And by thermal sensor elements, you can go from water to lubricant to cooling agent to thermoplastic, even to bodily fluids. Allow me to use another example. Imagine that you come to our design thinking room here to work on a flow controller for a new ventilation system to be used on an airplane. It might even be a little bit bigger than my paper airplane here. What do you think that will make it to our whiteboard as a requirement very fast? I imagine that most of us would think of reliability. Each of us will define the word a little bit differently, but who wants to sit in an airplane without a freshly filtered stream of air? So when we have a few engineers in the room, besides this type of requirements, very fast a different type of question will also pop up. They always remind me a little bit of Lego bricks because they go like which design blocks can be reused in other systems, or which additional functions do we gain when we select this sensor or this integration option. Let's have a look at the flow sensors from this point of view next. For this purpose, please allow me to introduce two of our pre-calibrated flow modules to you. The first one being the SFS01 module for gases. The beauty of a virtual show is that I can show it to you also close up, that it looks like this. And what it contains is an colorimetric flow sensor. And that means that we have a miniaturized spot heater on the surface to generate heat and then measure the temperature difference between two sensors located on both sides of this heater. In order to keep the total mass of this thin film structure as low as possible, these elements are actually positioned or placed on a extremely thin membrane, which creates the surface of the sensor. That's how we create an extremely fast and sensitive element. Here we are talking of a response time of 5 milliseconds or even less. What this system allows us as well is to measure the flow direction or determine the flow direction. At the same time, this colorimetric principle allows us to detect the flow direction. Just as for us, breathing is a sign of life, for a machine, the backflow can be a warning signal indicating a malfunctioning valve or that a sealing broke. So how can we evaluate the signal from such a sensitive gas flow sensor? First, we can of course accurately measure very small flow rates. In a well-defined flow channel, this is true in both directions. And a set point in one of these directions can then indicate a leak in the system. In this regard, An SFS01 sensor can be used in a similar setting as a differential pressure sensor. Additionally, we can also track the direction change frequency. And there you can think again of breathing monitoring, spirometry, as well as an industrial gas analyzer. With the right electronics, even more evaluation options are made possible. By integrating the signal, we can determine the volume even of the tiniest puff of air here, as you see in these graphics. In some cases, if the thermoconductivity of two gas media is sufficiently different, we can then apply an phi omega evaluation to our signal and use it to detect a change in the medium. In this context, it is possible to imagine an contamination detection system combined with a flow meter. The second module, which I'll be using as an example today, is an anemometer for liquids. Our flow-through sensor inside consists of an thin-walled tube with strategically positioned two different sensor elements which are soldered on the outside of this tube. It looks like this, very small passive element. And since the sensor elements have no direct contact with our liquid, we call it out of liquid or shortened OOL flow sensor. In an anemometer, we again apply heat, and the dissipation rate is then directly proportional to the mass flow rate of the liquid. So what functionality does such an OL module has to offer to us? This time we can measure the flow rate only in one direction, but we can at the same time harvest the temperature signal as an additional measuring parameter. When you think back to the wheel anemometer from Galileo's times a few slides back, this oil module is way more sensitive. This oil module is way more sensitive. Even a few droplets or bubbles create an reproducible signal which we can then digitalize, process, and feed to a controller. So let's have a look at the raw signal originating from an anemometer for liquids. As you can see here, with very little power, we can clearly distinguish between air and deionized water. The same principle applies also to other liquids, which can be highly viscous, even as a paste, or contain particles, such as used oil in a gearbox. On the right hand side, you can see also a simple installation which is from our testing laboratory downstairs. This is to demonstrate that you can use the same electronics, the same module to measure the flow rate and monitor your pipe systems, as well as to detect later on a few stray drops from a leaking faucet. I hope that you have found the described examples interesting and feel now inspired to imagine new sensor ideas. Please feel free to approach us during or after the sensor show to discuss them. Let's see if we can turn them into new control functions or maybe even unique selling points for your next generation product. In the US time zone, please don't be alarmed when your question shall be answered by my colleague Thomas Hall. Tom is also an ISD sales engineer working from Boston. He has prepared an interesting webinar which contains details on the individual flow sensors, and this you will find also in our virtual show, so you can check it out after the presentation. Thank you very much for your time. I look forward to your questions and hope to see you soon in person, either in Munich at the Sensor Show in December or maybe even here at ISC. Thank you very much.